5 years ago, BeonNAT set out to answer a bold question. Can Europe's forgotten low-productivity lands power a new circular bioeconomy? Today, the answer is yes, and the journey begins with the people who made it possible.
BeonNAT project is a project dealing with underutilized tree and shrubs species for being utilized in marginal lands. With the selected species, the BeonNAT project is dealing with producing up to 8 bioproducts. These bioproducts are essential oils, extracts, particle board, pulp for paper, biochar, and adsorbent for cats. And additionally, bioplastics for root from the saccharification of the woody part. So at the end, we are looking for producing 8 bioproducts.
And this work package is dealing with the production of the biomass, which is used in other work packages here in BeonNAT. So we agreed on the joint cultivation plan. We had a monitoring program on our test sites in Spain, in Germany and Romania. And so in general, it turned out that it is possible to cultivate these selected species on marginal lands, and we could confirm that all these sites are really marginal, but it is also tricky. There are many challenges in this regard to consider.
Firstly, 6 different wild and cultivated cross wastes were processed to obtain broths with an optimal concentration for interested sugars. Secondly, fermentation broths and the subsequent purification steps were performed to maximize the lactate and were performed the acid concentration to subsequently obtain the lactate, which is the monomer to obtain finally the PLA, which is the bioplastics chosen in this project. In addition, extracts from different crops has been assessed to obtain smart materials with antioxidant properties, avoiding the incorporation of additional antioxidant ingredients in the cosmetic formulation. The screening of all these procedures were initially performed at lab scale and then escalated up to pilot plant capacities using Ulmus pumila species crop.
Our work package has been mainly focused on the obtention of these extracts that are extracting the active compounds from the different plants, and we are producing final products for application as nutraceutical, pharmaceutical, feed or cosmetic industry.
Our mission was twofold: revitalize marginal lands and unlock 8 high-value product lines from underutilized trees and shrubs. Each work package tackled a different piece of that puzzle. Alongside the scientific work, we carried out a full value chain assessment to identify the most promising combinations of species and end products. This helped guide early commercialization efforts across multiple sectors, from cosmetics to packaging, proving that bio-based innovation can deliver both environmental and market value.
In an overall, from these results that we have from BeonNAT, we can say that Rosmarinus officinalis is a great preservative ingredient. It had excellent antioxidant and antimicrobial activity. Also, Cistus ladenifer is an excellent antimicrobial agent. As for the cosmetic properties, we can distinguish Ulmus as one of the best extracts that had a good cosmetic application.
And the results from Work Package 7 show, in general, that particle board, pulp and paper can be done from most of the species we've worked with, particularly some very good species like Ulmus pumila, Ditisus scoparius, but also Betula pendula. The main problem we found is the heterogeneity of the raw biomass, but it can be solved by improving the sorting of the particles and also the chipping.
The first step, choosing resilient species. From Ulmus pumila to Cistus ladenifer, our teams mapped, planted, and tracked growth across 70 hectares in Spain, Germany, and Romania. 3 growing seasons later, the plots delivered a steady stream of biomass, proof that even degraded soils can yield premium raw material when managed wisely.
We've been working with all the partners to process through pyrolysis the leftovers from the conversion step of the other partners of the project to make biochar and activated charcoal precursors. But not only, our partners took out the material we produced and made fantastic activated carbon out of that products. Now, We've been exploring the possibility to use oxidative and inert pyrolysis in this project, and one of the very interesting takeaways that we can present now after 5 years of work is that oxidative slow pyrolysis has the potential to really transform this conversion step by increasing efficiency and providing very good material properties, which can then be further leveraged to produce even better activated carbon products.
In Work Package 1, we made a screening of species. This means that we look for species of trees and shrubs harsh and adapted to bad conditions, marginal conditions, resistant species. So we found up to 16 species and were studied and analyzed in order to find which of these species should be afterwards selected for cultivation in marginal conditions.
That biomass fed the biorefineries. Essential oils and botanical extracts emerged first, ready for pharmaceutical, nutraceutical, and cosmetic markets. Next, we reimagined packaging. Using PLA derived from our feedstock, the team produced compostable films and trays, reducing dependence on fossil-based plastics. Residues never went to waste. Through pyrolysis, they became biochar and high-grade activated carbon, products that purify water, capture carbon, and enrich soil.
First of all, Alder conducted market analysis for all the bio-waste products explored by the project. Alder also conducted a value chain assessment to understand the species product combinations more suitable to be selected for the proposed biorefineries, for which Alder also prepared business models.
We are conducting the sustainability assessment to ensure that the BeonNAT products are in line with the EU sustainability goals covering social, economic and environmental aspects.
Every product line faced a rigorous life cycle assessment. Results show lower energy use, reduced CO2 emissions, and clear social benefits for rural regions. We developed certification guidelines and measured biodiversity and soil carbon gains, turning science into market trust.
We have analyzed how it's possible the certification of bioproducts that come from marginal lands that are not considered forest, in order to guarantee the sustainable origin and traceability, and to let these bioproducts comply with the sustainability requirements of global markets.
The plantations, and we are very interested in focusing on plants and beetles. Each year we had evaluations also for soil quality, and we tried to see if the plantations impact the biodiversity.
BeonNAT's blueprint is now proven. Marginal lands can host resilient species, power green industries, and boost local economies.